Okay.
What's up, bro?
We got part of this done yesterday. Oh, here it is. There's my boat motors. Right there. And then we did this. Oh yeah, there's our aliquot. So we, I believe, did part A and part C. This is taken right out of the book. I don't remember what part B was, but it was not something that we needed to do in class. It was probably very easy. Why? He doesn't like it when I do that. Okay, so I'll just get that out of there. I believe, if I remember right, we calculated 2 of the concentrations yesterday. Okay. What I'd like to do is, if I could, I'm not going to do A and C. Well, I am going to do those because we need to refer to that. So we have our sodium hydroxide and our iron 2 chloride. Our precipitate is going to be the FeOH taken twice, and then sodium chloride. Balance. Okay. So there's our working chemical equation. And just so I can bring this back, we began with 0.02 moles of this and 0.02 moles of this. Now, when you look at the chemical equation, we need twice as many moles of sodium hydroxide to use up all of the iron chloride that would be there. I don't have twice as many moles of sodium hydroxide. I actually have the same number of moles. So since I don't have twice the number of moles of sodium hydroxide as that one, sodium hydroxide runs out first. Get the feel for limiting reagent. We use it a lot. Not just this chapter and last chapter. We use it all year. If you're not seeing the whole reasoning through the limiting reagent, 2 things. Either stop by and we'll talk about it. I'll see if I can kind of walk you through it a little bit better. Or you can always just take that amount of reactant and go to a product, from that amount of reactant to a product. Whichever one makes less is the limiting reactant. And that will always work. It just takes a long time, and I'd rather go fast. Okay? So we've decided that this one is the limiting reagent. Okay, now with that, let's go ahead and kind of start part D over again. I'll do the OH first because that's the limiting reactant. Whichever one is limiting is going to run out first. That's it. It's going to completely run out. So at the end, the limiting reagent, because the hydroxide ion was kind of gobbled up by the production of that precipitate, there is none of the hydroxide ion at the end. That is not true for the sodium ion. Why?
Because it dissolved.
Because sodium ion is not taken out in making a precipitate. The sodium is, it didn't get used in the reaction, so whatever amount of sodium that was dissolved at the beginning is still dissolved, and so we don't, I guess what am I trying to say? We have to calculate its concentration. It's not going to go to 0. Even though it's been declared that sodium hydroxide is the limiting reagent, the sodium ion was actually a spectator. It's only the hydroxide that actually got used up out of it. Okay? So, the sodium ion, still need that chemical equation right there. The sodium ion goes like this. Remember, we're looking for a molarity, a concentration. Moles over liters. How many moles of sodium did we start with? It's right there. We started with 0.02 moles of sodium hydroxide, and so since there's 1 sodium in every 1 sodium hydroxide, then we still have 0.02 moles of sodium that's dissolved. But now it's dissolved not in 100 milliliters like it was before. Now it's in 200 milliliters because the volumes got added together. Are we okay with that? How you add the volumes if you need a concentration at the end? Okay, so that divided by that is going to give us 0.1. So we're halfway there. We've got 2 of our concentrations. We just need the other 2, and that's it. The iron. Did we do the iron yesterday? Okay. Now the iron is the toughest one because some of the iron got taken out in making a precipitate, and some of it did not. So let's do that over here. Here's the, there's a colon. The iron, we started with how many moles of iron? 0.02 moles. How many do we use?
Question mark.
Uh-huh. See it. 0.01 moles was used. Why? Because all of this got used, and for the sodium hydroxide, you need half as much of the iron chloride, or the iron ion that got used up. So because it's FeOH taken twice, for every 2 hydroxides, you're going to use 1 iron. So if we use 0.02 moles of hydroxide, we only use 0.01 moles of iron. You with me? So that means we're left with the concentration of iron being 0.01 moles, still dissolved, that hadn't reacted or precipitated, divided by 0.2. So I'll put the answer over here. Iron concentration is 0.01 divided by 0.2. Can you do that? If you're not sure, put it into scientific notation, the top and the bottom, and evaluate that way. That'll be much simpler. Like if it's on a test, if you have any more decimal places than that, scientific notation works well. So it's 0.05 molar is the final concentration of iron. The Element song. This is a little bit distracting. You want me to close the door?
Yeah.
I'm sure that's more entertaining than what we're doing here, so I'll leave it open. The chloride ion. Now stay with me on the chloride ion. How many moles of chloride ion did we have to begin with? 0.04 is right. We had 0.02 moles of this compound, but notice in this compound, for every 1 FeCl2, there's 2 chlorides. So if I could just take that down here, 0.02 moles of FeCl2 times 2 Cl, or 2 moles of Cl, for every 1 mole of FeCl2. That's how we get the 0.04. So when you want the final concentration of chloride ion, you're going to have more chloride than you have sodium because we started with more chloride ions dissolved. You okay with that? So, I'll just do it right down here at the bottom. Chloride ion is going to go like this. And it was a spectator, so none of it got used. This is kind of nice that only one of them we had to worry about the beginning and the ending one. So the chloride ion is 0.04 moles over 0.2. And 0.04 divided by 0.2 is 0.2 molarity. So all 4 of these ions all have different concentrations at the end. That was why I chose, some of the problems in the book are easier than this. I chose a difficult one so that we could talk it through and you could see what you have to do to find final concentrations of things. Any questions on anything on this? Did I lose you in any part of it? Yep.
I'm a little confused. When you went to the arrow, and then you said it's 2 mole of chlorine per mole iron chloride, because in the RQ or the reading quiz, it was like different. There was always 2, but you said like
in this one,
right.
Let's see.
Bottom right. You did
Well, I was going from one thing to another in the bottom right.
Okay.
But we were just talking about this, and I had mentioned too that the number of moles of hydroxide that you have here, you would have to multiply the volume times the molarity and get the number of moles of calcium hydroxide, and then multiply by 2 because there's 2 hydroxides in every one of those.
Okay.
So this is different than what we did. I mean, what we were doing in that exercise is different from this, because this case I was going from one of those to 2 of those, going to a different substance. But yeah, the number of moles of hydroxide, you would find the moles of that compound and then multiply by 2 because there's 2 hydroxides in there. Okay. Anybody else on that? Okay, now the next thing I'd like to do is I'm going to throw another question like this. It's got multiple parts like this one did. I'm going to give you a few minutes to try to work through it. I want you to consult with one another and work together and take your time on this. I'm not going to interrupt you right away. I'll just give you several minutes to try to work through this. Did it again. Okay, now having done that one before, I'm quiet for, 5-10 minutes maybe. Unless you have a question, you see how you do with this. I'll just leave you alone. And don't feel bad about turning around and talking to somebody else. I want you to.